Hello, so today we're going to be talking about generators. I'm going to just lead you through the science behind how we make electricity in things like bicycle dynamos or on the larger scale in power stations. Okay, so as you know, around a magnet there is a magnetic field, and you can draw the field lines like this, and they go from north to south, and they're in a certain pattern around whatever kind of magnet you have. And there was a Danish scientist called Hans Christian Ørsted, and he said some stuff about magnets and electric fields. Now, he noticed there was a link between electrical fields and magnetic fields, and he said when electricity passes through a wire, it creates magnetism. Okay, but you don't have to take that on trust. You can try this, and I hope that you'll try this in the classroom. And what we're seeing here is that the pink rectangle with the yellow dots, that's supposed to be a wire, and those yellow dots are supposed to be electrons. And as they pass through that wire, you can see a circular magnetic field being set up around the wire. And we can see this with this experiment here. Here's a switch, someone's turning it on, there's an electric field in the wire, and you can see there's a magnetic field. Now the magnetic field goes, turning it on, turning the wire on, magnetic field. Okay, so you can see that electric fields and magnetic fields are linked. Okay, so we can see that whenever there is an electric field, it creates a magnetic field, which is what Ørsted said. So, if you can make a magnetic field by changing the direction of an electric field, can you make an electric field by changing the direction of a magnetic field? Okay, so can you get it to go backwards in the reverse? So here is induction. Here is a video of induction. These things always take too long. Alright, so here we have an ammeter and a magnet and some coils that are not connected to any power source. Okay, when the magnet goes in, can you see there's a displacement in the needle? Okay, so we can see an electric field is being set up in this ammeter just by moving a magnet. Okay, so there the magnetic field is making an electric field, but only when the magnet is moving. If the magnet is still, there is no electric field. If the magnet is moving, then there is a field. Okay, so here's another version. Okay, different type of ammeter. So we can see straight away moving a magnetic field near a wire makes a current in the wire, and we call that induction. Okay, so here's another scientist, Faraday, and he said the induced voltage in a closed circuit is proportional to how quickly the magnetic field changes around it. Okay, so he's saying exactly the same thing as Ørsted, but he's putting numbers on it. So here's a generator. This is a Turkish animation, and as you can see, you can keep the magnet steady and move the coil, and you get this electric field. Okay, so you're generating an electric field from a magnetic field. We've got an animation here. So as you can see, here is the coil, and it's turning in a magnetic field, and you are making a voltage. Okay, so as it goes round, there is an induced voltage in the coil, which you can measure. Okay, that was worth the wait. Alright, so dynamos look like this. You have your coil, which is red, and you've got a magnet that's turning around. So as you pedal your bike or turn a crank, it turns the magnet, which induces a electrical field in the wire. Okay, power stations, for example in Skagerrak, have these enormous coils. So you are turning the magnets around inside these coils, and it makes enormous voltages. And of course, wind turbines, same deal. The wind turns the magnets, and there is a current induced in the coils around them. Okay, so in the lesson you will be doing these as experiments, and you'll be proving this to yourself and trying to make a generator yourself. Okay, so I look forward to it and see you there.